Hi everyone. So today we will discuss the concept of radioactivity and displacement law. So what is radioactivity? In an atom, the nucleus consists of neutron and proton, and electrons are revolving around the nucleus. The nucleus is positively charged, electron is negatively charged. Now what happened? Nuclear may be stable and it may be unstable. What is criteria? The more n by p is equal to 1 means n by p ratio, neutron and proton ratio, if approaches to unity, the nucleus is stable. And if n by p is farther away from unity, it is so far from unity, the nucleus is unstable. So no nucleus wants to be in unstable position. Each and every nucleus wants to convert itself from unstable to stable position if it is already unstable. In this process, what it does, it adjusts the nucleons. It adjusts the nucleons. That we will see further how it adjusts. It adjusts the nucleons and alpha emission, that is a particle, means helium nucleus. That I will tell separately. Beta emission and gamma emission. So beta is also a particle and gamma is a energy. EM radiation. This is gamma is a EM radiation, energy. So these three types of emissions are observed in unstable nucleus. With emission of these rays, alpha, beta, which are particle, and gamma, which is energy, the unstable nucleus convert into stable nucleus, and this emission is called radioactivity. Radioactivity. Correct? So this is the definition of radioactivity. And now we will see how nucleus adjusts the nucleons by emission of alpha, beta or gamma to achieve this n by p ratio equal to 1. So let us see first mechanism of beta emission. Beta emission. So beta emission occurs in neutron rich nuclides. Correct? Suppose an unstable nucleus have more neutrons than protons. Here neutrons are more and protons are less. So this is unstable nucleus. This we call parent nucleus. So here n by p ratio must be greater than 1. For stability, what is it has to achieve? It has to achieve n by p ratio is equal to 1. So in this process, what it does, it pick up one neutron and converts it into proton, and one electron is generated where inside the nucleus. It is not in the orbit around. These orbit electrons are different. They are the structure of the atom. But here, due to adjustment of nucleons, the nucleus converts one neutron into one proton, and one electron is generated in the nucleus, and if it has some kinetic energy, it will come out of nucleus, and that we known as beta particle. So this is beta emission by a nucleus. Correct? So with beta emission, this parent nucleus convert into a new nucleus where neutron and proton almost becomes equal, means n by p ratio nearly equals to 1, and atom achieves the stability. Here one thing should be noted. The parent nucleus are different and daughter, this we call daughter nucleus. So daughter nucleus is completely different element, and parent nucleus is completely different element. So this is the basic difference between chemical reaction and nuclear transformation. In nuclear transformation, the atoms are changed, but in chemical reaction, atoms are not changed, just they recombine with each other. So one thing also observed here, during beta particles, one proton is increased and one neutron is decreased. So what will happen for this nucleus? या new nucleus में क्या होगा? A is mass number and Z is atomic number. For parent nucleus, then daughter nucleus में क्या होगा? A unchanged and Z increased by 1. Z is increased by 1. Means what? The parent nuclei will jump one step further in periodic table because atomic number is increased by 1 unit and periodic table is arranged on the basis of increasing atomic number. Correct? Now next we will see the mechanism of alpha emission. Mostly it occurs in heavy nucleus. Here nothing like neutron rich or proton rich. Only thing is that N by P ratio differs from unity. Means it is far away from unity. To adjust this value towards the unity, what this nucleus does, it separates out 2 proton, here also plus, 2 proton and 2 neutron in form of helium nucleus. Okay? Because helium nucleus has 2 proton and 2 neutron, so 2 proton and 2 neutron inside the nucleus becomes as a separate nucleus, that is helium nucleus, and it separates out from the parent nucleus. Parent nucleus. So what happens? It will separate out from the parent nucleus. So here one new helium nucleus will be separate out or ejected out from this parent nucleus. So this 2 proton 2 neutron, this is helium nucleus, and rest nucleons will remain inside the nucleus. So here you will get daughter nucleus. It's also a different nucleus. This helium nucleus is called alpha particle. This helium nucleus is called alpha particle, and this with some kinetic energy it will escape out from the parent nucleus. So how we will feel if parent nucleus ejected some nucleus, that is helium nucleus, and what remained, that is the daughter nucleus, and it is totally different from the parent nucleus. In this process, if you see, so 2 neutron and 2 protons are reduced from parent nucleus. Means what? A, that is mass number, is decreased by 4. Is decreased by 4. And Z, that is atomic number, it is nothing but number of protons inside the nucleus, is decreased by 2. So in this process, what will happen? Once alpha is ejected out, the parent nucleus will jump backward 2 steps. Why jump backward 2 steps? Because atomic number is reduced by 2. Now what is gamma emission? Gamma emission is not independent emission. It associates with beta emission to adjust the energy of the nucleus. Alpha and beta emission adjust the nucleons, and gamma emission adjust the energy of the nucleus. This is the concept. So let us solve one example on radioactivity displacement law. So here is the question: how many alpha and beta particles emitted when 238 uranium-92 converts into 206 lead-82? So here you see change in mass number will be 238 minus 206, and that is equal to 32. Change in atomic number is equal to 92 minus 82 is equal to 10. How this transformation occurs? Because uranium emitted some alpha particle and it also emitted some beta particles. Since mass number is changed by only emission of alpha particle, so first we will see how many alpha particles are emitted. So one alpha particle reduces mass number by -4 and atomic number by -2. One beta particle doesn't change mass number and it increases atomic number by 1. So when delta is 32, we can easily get out how many alpha particles would have been emitted. So number of alpha, 32 is the change, net change, and in one alpha emission there is a change of 4, just divide by 4, 8 alpha particles will be emitted out. During this emission, how much delta Z has been changed? So delta Z must be equal to 8 into 2 is equal to 16. So there must be a shift of 16 in atomic number, but there is a shift of 10 only you got. Only 10 you got. Means there is increase of 6 unit in atomic number. How this occurs? Because along with alpha emission, the atom also emitted beta particles. One beta particle increases 1 unit atomic number and there is a 6 unit atomic number gain is there. So how many beta particles? 6 divided by 1 means 6 beta particles will also be emitted along with alpha particles. In this type of questions, what you will do? First you calculate number of alpha based on change in mass number, and then to adjust the change in atomic number, calculate the beta particles. So hope this video cleared your concept about radioactivity and displacement law. And if you like this video, please give a like button and please subscribe my channel. Thank you.